என்னடா வண்டி தினம் சவுண்ட் இருந்துச்சு, என்னடா பிரச்சனை?
என்னடா கியர் பாக்ஸில் கடை சவுண்ட்.
ஹாய்டா, ராம் சுரத் கார்த்திகேயன்.
ஹாய்டா.
என்னாச்சுடா என்ஃபீல்டு வச்சு ரோட்டில் நின்றுட்டு
லட்சு பிடிக்கணும் கியர் பிடிக்கணும்டா, டப்பா பிடிக்கணும்டா.
என்னடா ராம் புது என்ஃபீல்டாக இருக்குது
தெரியாமல் பண்ணிட்டா.
கேம் தெரியாது.
தெரியாது.
சரி நான் சொல்கிறேன் கேட்குறியா? கேம் பற்றி ஃபுல்லாக டைம் ஆகும்டா.
சரி சொல்லு.
ஓகேவா?
Here we will discuss about the manufacturing process of the gearshaft.
அண்ணா எத்தனையோ ஃபுட் வருது போகுது.
ஆமா.
ஆனா மட்டும் ரொம்ப காலமா இருந்துகிட்டே இருக்குல்ல?
ஆமா, இருந்துகிட்டே இருக்கு.
அப்ப சொல்லுங்க, இந்த யாரு கண்டுபிடிச்சாங்க?
As Shevak said, everyone talks about the gears, but we would like to cover the manufacturing process of the gearshaft because it supports that gears which rotate at the higher RPM. So it's important to understand how it should be and what is the material that needed to manufacture this shaft and what is the process that it undergoes. So we will see all those things in upcoming slides. Usually gearbox have the 3 different kinds of shaft, that is input shaft, lay shaft and output shaft. First, what is shaft? A shaft is a revolving rod that transmits the motion or power. It is an essential part of the overall transmission that bear the shear stress and torsion. In gearbox, the output shaft carries the energy from input shaft and operates at the different speeds according to the gears and gear ratio.
Gearshaft. What is it made of? Here are the basic gear materials used for making gearshaft: cast iron, steel, aluminum, bronze, brass, plastic, stainless steel and carbon steel. The next one is basic manufacturing process of gear. There are a lot of methods for gear manufacturing. Basic steps involved are: firstly, we will be preforming the gear blank with or without gear tooth, followed by heat treatment process for the gear blank only if it is required. Secondly, we will be machining the gear plank to get appropriate dimensions. Finish the preformed teeth by machining process. Hardening process for gear teeth comes into play. Thirdly, final finishing of the gear teeth like shaving, grinding process are made, and the final inspection of gear wheel is done. How it's made? The process involved in gearshaft manufacturing are sawing, normalizing, forging, facing, turning, spline rolling, gun drilling, parting, cross hole drilling, countersunk drilling, deburring, heat treatment, followed by straightening, reaming, grinding, hard grooving, polishing. The quality checking process are ball pressing, MPI inspection, visual inspection, and then final inspection is made.
The first process for the manufacturing of gearshaft includes sawing. Sawing is a process wherein a narrow slit is cut into the workpiece by a tool consisting of a series of narrowly spaced teeth called a saw blade. Sawing is used to separate work parts into 2 or more pieces or to cut off an unwanted section of a part. And the shaft is cut into a certain length of required size. Following the sawing, the forging takes place. Forging is a manufacturing process involving the shaping of metal through hammering, pressing or rolling. These compressive forces are delivered with a hammer or die. Forging is often categorized according to the temperature at which it is performed: cold, warm or maybe hot. And for manufacturing of the gear shaft we follow hot forging. After forging, normalizing process takes place. Normalizing is a heat treatment process that is used to make a metal more ductile and tough after it has been subjected to thermal or mechanical hardening process. Normalizing involves heating a material to an elevated temperature and then allowing it to cool back to room temperature by exposing it to a room temperature air after it is heated. This heating and slow cooling alters the microstructure of the metal, which in turn reduces its hardness and increases its ductility. Now, it is often performed because maybe another process decrease the ductility and increase hardness. So the normalizing process takes place. Facing and centering process is done in a turning machine that can machine both ends of a piece of bar stock simultaneously. And it is done to hold the shaft in horizontal position for the further machining process. And this includes the headstock to move up and down, and it consists of a chuck which is used to hold the workpiece, and these 2 wheels are used to move this working bed, and the Coolant supply is used to supply the coolant for the cooling purpose of the workpiece.
Turning is a machining process that gives shape to a raw material such as plastic, wood, metal. It is typically done using a machine called lathe, which can be CNC or manually controlled. Turning is the process of removing the material perpendicular to the axis. Here, series of steps having different diameters is produced. Gear turning technology requires proper equipment, and gear motion is equipped with a range of turning machineries. In this slide shows the step turning process. Spline rolling. Spline rolling is a proven, high production, cost effective process for generating complex geometries in metal parts. This process utilizes paired racks mounted in a spline rolling machine to roll complex geometric shapes. In this process, shaft is made to roll on the teeth bed where the compressor forces acts on it, which the machine is CNC controlled, and also splines are produced. The entire process takes roughly 4 seconds to complete. Splines and serrations are typically used in torque transmitting applications requiring a precision fit to a mating part, as opposed to nulls which generally do not require a precision mating fit. Half shafts, drive shafts, electric vehicle motor shafts, and power takeoff shafts are common types of spline and serrated components. In this slide, the image shows is a shaft where two gear dies are used to roll the spline rolling in the given shaft. Gun drilling is a deep hole drilling process that uses a long, thin cutting tool to produce holes in metal at high depth to diameter ratios. This process is effective in diameters from 1 to 50 mm. They can produce thin wall parts such as axles and power transmission shafts. For instance, drilling a 20 mm axial hole through a heavy 30 mm diameter shaft makes the shaft much lighter while maintaining its stiffness. This lighter shaft has less rotational inertia, which in turn reduces energy consumption. The image and slide shows a process where 2 to 3 gear shafts are gun drilled at same time to long depth. The gun drilling process is able to drill deep holes beyond what is possible with conventional machines and tooling such as twist drills by using high pressure coolants for clean chips even at extreme depth.
Next is the cross hole drilling. Cross drilling is where a round hole is drilled through the middle of a round bar. It is usually put to ensure the flow of coolant around the shaft. This is done after the gun drilling. It crosses the path of the existing gun drilled holes. Next process is the countershank drilling. Countershank drilling is usually done on the existing holes to make them conical up to a certain length. It is used to ensure that flathead screws or fasteners sit against the workpiece. Next process is deburring. It is the cleaning process used to remove the metal chips that is burr in a material. Air gun is used for this purpose where chips washed out from the workpiece. It usually requires the 2 to 3% according to the manufacturing of the material. Means it only requires the low workforce.
The next one is heat treatment process. Carburizing is a heat treatment process that produces a surface which is resistant to wear while maintaining toughness and strength of the core. This treatment is applied to low carbon steel parts after machining, as well as high alloy steel bearings, gears, and other components. Carburizing increases strength and wear resistance by diffusing carbon into the surface of the steel. This treatment is applied to low carbon, slow carbon machining. Strong and very hard surface parts of intricate and complex shapes can be made relatively low cost materials that are readily machined to heat treatment. Most carburizing is done by heating components in either a pit furnace or a sealed atmosphere furnace and introducing carburizing gases at temperature. Straightening. In a perfectly straight shaft, the centers of each shaft cross section from end to end of the shaft lie on a straight line. A shaft is bent if that is not the case. In a bent shaft, the axis of the shaft is different than its axis of rotation. The range of orbit caused by the shaft bend is defined as a shaft runout and is typically measured in terms of TIR, which is total indicator reading. Bent shaft causes damage to bearings, seals, and couplings. In practice, the bent shaft straightening process sometimes simply create additional stresses in the material that oppose the material stresses that caused the initial bending. As a result, the shaft material fibers that initially caused the shaft to bend remain in a stressed condition after the repair is complete. The shaft straightened in this manner can initially indicate straight. However, the long-term success of the balanced stresses is doubtful and unpredictable as those material stresses can relax over time. Reaming process. Reaming is a cutting process that involves the use of rotatory cutting tool to create smooth interior walls in an existing hole in a workpiece. The rotatory cutting tool used in reaming is known as reamer, like drill bits. Reamers are also remove material from the workpiece on which they are used. However, reamers remove significantly less material than drill bits. The primary purpose of reaming is simply to create smooth walls in an existing hole.
Hot grooving is generally a surface finishing process and it is done on the existing grooves that are made by turning, grinding and polishing. Grinding process is the process of removing metal by the application of abrasives which are bonded to form a rotating wheel. When the moving abrasive particle contact the workpiece, they act as tiny cutting tools, each particle cutting a tiny chip from the workpiece. It is a common error to believe that grinding abrasive wheels remove material by rubbing action. Actually, the process is as much as cutting action as drilling, milling and lathe turning. The polishing process involves creating a smooth and shiny surface by rubbing it or by applying a chemical treatment. The final thing obtained from the polishing process have a specular reflection. The polishing process removes the material at the micron level, and the main thing about the polishing process is the polishing process should carried out in an area where the environment is maintained at a particular temperature, and this is due to avoid expansion and shrinkage of the material.
Quality checking process. MPI, magnetic particle inspection, is a non-destructive inspection method that detects linear flaws located at or near the surface of ferromagnetic materials. Ferromagnetic means strongly attract to both the poles. This forms primarily a surface examination method. It is a very effective method for the location of surface cracks, breaks, pores, collapse, lack of sidewall fusion in welding, etc. in the magnetic material. Shaft is first magnetized and is immersed in coolant solution with magnetic particles suspended. This shows surface cracks on the shaft which would appear as clear and defined lines to eliminate the entire crack running through the material. Image in the slide shows how crack is detected in MPI under the ultraviolet light. After the crack is detected, the shaft is then demagnetized. And final inspection. Set of workers inspect the shaft for any kind of defects, and they use some tools for this, namely depth gauge to check the depth of drilled hole, gun drilling, countersunk drilling, cross-hole drilling process, snap gauge to check the diameter of the grooves in hard grooving process, ring gauge to check the diameter of shaft ends after spline rolling process. Apart from mentioned in slide, dial gauge is also there for measuring the runout in shaft after bending. That is used in straightening process. Image in the slide shows shaft inspected with optical system which measures all the teeth, profile, thread and dimension measurement. If results obtained is more than the tolerance level, shaft is rejected and sent for rework. Even after rework, if the shaft dimensions are not satisfactory, then the shaft is rejected and is not used. In many manufacturing plants, the final inspection of the shaft is always done in a cold environment. Washing. Gear shafts are usually cleaned in a wet chemical batch process with water-based cleaning agents or solvents. Cleaning is followed by a single or multi-stage rinsing process for which deionized water is frequently used during the last rinsing cycle. This prevents the adhesion of residues left by the cleaning agent or surface spots on the gear wheels, which might impair processes such as hardening. In order to be able to achieve the desired cleaning results within short period of time, ultrasound used for cleaning gears and gear shafts. Plasma process, which is microcleaning, used where gear and shaft treated as individual parts. Contaminations removed from complicated shapes with tight radii, undercuts, drill holes, and slots. Packaging. Gear shafts are packed in double-wall cardboard boxes, which offers string protection and durability. For our assignment, we selected manufacturing process of 8-speed turbine gear shaft, and this is how the shaft looks at the end of the manufacturing process.
Gearshaft applications. The gearshaft applications are factory automation, packaging machine, industrial robots, automatic cutting, welding machine, food processing machine, agricultural machinery.
புரிஞ்சுச்சாடா உங்க 2 பேருக்கும்?
புரிஞ்சுதா?
இவ்வளோ விஷயம் இருக்காடா கியர் பாக்ஸ் பற்றி. ஓகே, இதுக்கப்புறமா நான் ஒழுங்காக கிளச்சு பிடிச்சி கியர் போடணும்டா.
ஓகேடா, நல்லதுடா. சரி ஓகேடா, நான் கிளம்புறேன். பை. பாய்டா. பை.